Hey all, how are we doing? Today we're going to make something that's very, very cool. I'm excited about this one. We're going to recreate the play zone from PUBG, Fortnite, Survival of the Fittest. That blue circle that contracts as the game goes on. And all we'll need to get this thing done is just a sphere, a vertical fade texture. We'll use a texture and not just the vertical fade node. I'll explain why later. The split hex mask and just a cloud, just a rendered clouds mask. And you can pick up all these things from my texture pack. You can find it on Gumroad. There'll be a link in the description. But let's just jump straight in. Let's just get started. So we'll make a new material. I'll just call it Circle Mat. And we'll open it up. So the first thing that you want to do is just grab your main material node here. We want to make sure that we set it to, well, surface. Translucent, we want it to be unlit. And we want it to be two-sided. We'll be able to see from the inside and the outside. So we'll just hit save. I'll grab our textures here and drag them in. And we're ready to get started. So first thing I think we'll do is the actual color, like the actual highlights. And to do that, we'll use a combination of a few different things. We'll start just by grabbing a texture coordinate node. We'll plug this into a panner. Panner, there it is. Set the speed, say, I don't know, we'll go 0.5 in both. And we'll plug the coordinates of our panner into our cloud texture. So next up, I'll send this through a clamp. We'll just clamp some of these values just going forward to 0.15. Just bring up the bottom values a little bit. Then feed this clamp into a multiplier, because we'll be using a Fresnel next. So drag off from the multiply, get a Fresnel shader, and we'll right click and preview that. And you can see sort of what we're going for, kinda. So make a new scalar parameter, just hold S and click. This is our cloud Fresnel. Set it up to 20, say, something fairly high. Plug that into the multiplier and you'll see it change. Yeah, so we have a little bit more going on now. But we kind of want a sort of higher kind of contrast. We want it to sort of pop a bit more. So drag off from the Fresnel and bring up the cheap contrast node, which is one of the ones built into the engine. And then another scalar. This is just the highlight contrast. Highlight contrast. Set this, we'll set it at 0.5. Because these are all values, we're going to instance the material shortly, and we'll be able to manipulate these all in the world. So it's not necessarily, necessary to get these right the first time. Okay, so that's looking a bit better. This gets our sort of cloud highlight around the back, and we can probably slow this down a bit. We'll go down to 0.2. These could be scalars as well, the speed, but I'm not going to worry too much about it. And from there, well, this gets us the basic highlights. We'll just let between two colors. But we can also do some other fairly cool things, like create an effect where the circle touches the ground. There'll be a bit of a glow at the point of contact. So we'll grab ourselves a depth fade node, and we'll preview this. We'll see what happens. Yeah, nothing. It needs to have something to feed into. So we'll come out of the cheap contrast into a max node, get the maximum values, plug in our depth fade. And actually, we might have to invert the depth fade. We'll just grab a 1-, which is just a little node that inverts any of the values that come into it. And then we'll get a lerp, and we'll get two colors. Convert these to parameters. We'll need a circle color. And we'll also need a highlight color. And I went pretty basic for this. We'll set them to, I'll just crank it up to blue. Oh, what's happened? There we go. Blue, and the highlight can be white. So plug in your circle color into A, your highlight color into B, and the results of your max node into the alpha. And then plug the lerp into emissive. There we go. Now we can see what's cranking. So you can see where the sphere is touching the ground, there's that glow that's appearing. This will be affected throughout the world once the dome is in. So that covers our basic colors. Next up, we'll do our hex pattern. So this is the split hex texture. Get another texture coordinate node. I'll just copy this one because it's a long one to type. Feed this into a multiplier and get yourself a scalar. This is the hex UV multi. We'll call this one near. Show you why shortly. Plug that into UVs. Duplicate this node. What's going to happen here is we're going to have the texture change. It's going to get bigger when we're further away and smaller when we're up close. Just so we're not looking at crazy stretched out, blown out textures when we're up close to the dome. It gets to scale down. So set your near multiplier to, let's say, 200. And we'll rename this guy the Hex UV multi far. And it'll be something really low, 10. Make them appear quite big. And we can do the odd thing, like we can preview this node. We can see what they look like when they're far, and we preview this one. See what they look like when they're near, which is quite multiple. So start previewing that. We'll lerp these two together. You can hold in L and click to get yourself a lerp. The near one into A, the far one into B, and then we'll do some trickery to make sure the transition works as intended. First of all, grab the absolute world position. I think you'll have to type in just world position. This just gets the actual point of the pixels of the material, and we'll get the camera position, which will get us the position of the camera and what the camera's looking at. Come off either one of those, get yourself a distance node. This will calculate the distance between the two. There it is, utility distance. Plug them in. Put it into a divide. It's a bit like blueprint maths, but just with materials. And we'll make ourselves another scalar. This is our blend distance. So this figure will dictate at what distance the transition occurs. We'll crank this up to something high, 6,000. Plug it into the divide. Then we'll crank it by a power just to make it pop a bit more. Power node. And I just used a constant for this, but you can use whatever you want. You can make this a scalar if you like, and plug it into the exponent. Come out of the power into a clamp, so that we don't get any extraneous values, any big blown out figures. And this will be the alpha of our lerp. Now let's see if we can preview this. Yeah, it might not work too well. Yeah, it's not going to work too well in the preview. Anyway, we'll just move forward. Next thing is a Scanline Effect, which I thought was pretty cool. I used it in a different material once, and I thought I'd just adapt it for this. Add something else. So we'll go from we got our Scanline material here. We'll make ourselves a panner. You can just hold P and click, and a scalar. It's S and click. This is our Scanline speed. And the reason that we're using a texture for this and not just the linear gradient node is because the linear gradient node won't work with panners. It won't actually scroll on the UV coordinates. We need an actual texture so that we can actually control its movement. So in the Scanline speed, set this to minus 0.2. Plug it into speed, and then the coordinates into UVs. We don't really have to append the X and Y values for this one because it's the same horizontal. So as in, it's going to tile horizontally, just not vertically. So by plugging directly into the speed, we're just looking at changes to the vertical travel of the texture. From this lerp, we'll get a multiply node, plug in the texture, the Scanline texture, and then we'll make ourselves another Fresnel node so that we can just play around with lighting a bit more. Let's make a new scalar. This will be we'll call it the texture Fresnel. Make it something like 15. Plug that into the exponent, and we'll add it to the results of this multiplier. Just like that. And what's next after this? Oh yeah, we'll hook it up with our highlights and our colors. the command of the add into another max node. I'll use the B value just so the shapes make sense. And then from this max node up top, we'll plug that into A. And then let's see, how's this going to hook up? We'll get another clamp out of here, out of this lerp from our hex textures, and we'll clamp the ceiling value at 0.1. Get ourselves another add node. It's partly experimentation, but that's the key to getting good. Just play around with stuff and see what happens. We'll add that to a multiplier. This will be the scale of the opacity, this multiplier, now that everything's combined. So hold S, click, opacity scale, and we'll set it to 2.5. Plug into B, and then the multiplier into opacity. There, if you can see that in the preview, we have our hex. We've got our scan line moving down. It's all looking very attractive, and now would be a good time to play with it in the world, I think. So just save the material, come back to your editor, make an instance of this material, and then we'll drag in our sphere. I'm using a fairly high poly sphere, but you can use the shape sphere that comes with the starter content. We'll make our sphere quite big and drag the instance on top. So it's rather huge, and see as we zoom out, see how the shapes are really big on the sphere here. Also seems to be upside down. I'll turn him over. Could also reverse the speed of the. In fact, I'll do that. I'll just come back into the material, come to the scanline speed, and instead of minus 0.2, we'll just make it positive 0.2. Would have done that in the instance, I guess. Anyway. So there we have it, and we see our cloud Fresnel here on the side, just for a little bit of extra added effect. And you'll also notice that it's interacting with the objects here, with the foliage. So as it moves around, as it touches things on the ground, it's going to create this glow effect at the intersection, which I quite like. I thought it'd be a cool thing to show off. So let's go back to our material, and we'll play around with a couple of other things. We have some finishing touches, because once we hit play, you'll notice that things are quite dense. Might change those figures now. So where are we? Hex UV multi, near and far. The near one, that can be lower. Maybe 100. Cool. And let's see if we can make this a little bit bigger. We'll change the scale again up to 20. Alright, so we'll pull away, and you can see the transition of the texture on the boundary of the sphere. We'll come up close and it changes. Great. Alright, we're on track. So, what is next? Yes, we'll go back to the material, and we'll make a few changes, because if we hit play and look up, see, we get this ugly looking UV tiling point at the top, which we can do without. So back in your material, let's make ourselves some space here. Let's drag this over. We'll grab our vertical fade texture, go into a multiplier, and then into another scalar. This is the opacity height, and that'll be set to 1 for now. Where are we? 1. Hook that up. And then we'll need 2 lerps, one for the emissive and one for the opacity. This will be the alpha of both. We want the A input to both of these lerps to stay at 0. I'll just use a constant just so we can all see. And then the B value is each of our final results. One from the emissive and one from the opacity. And just plug them into the material. Hit save. And then back in the world, well, let's open up our instance again and play with these values. So let's tick all these boxes. It is upside down. So for this one, will come from the, let's move this out of the way, will come from the texture into a 1-, and plug that in. As it was going from the bottom of the texture to the top, and we want it to be masking out the top. Opacity height. Bring that down a bit. It's just going to hide the sky. And then to make the textures pop again, we'll need a glow crank. So where are we with emissive? We'll come straight from out here. So we'll get another scalar. This is our glow crank. Set to say 15. And this goes into a multiplier, which will plug into emissive. Then hit save. Then back in the editor, we'll have our glow crank here, which we'll set up to, I don't know, 30 maybe. And we can change around with our colors a little bit. I might like a slightly lighter blue. Not too light. And the highlight color could probably be brought down to, say, I don't know, something like that. Make them pop out. Maybe even crank this up to 50. So it's really showing itself. Could even be brighter. Maybe saturate our blue a bit more. And the crank 75. And we can also hit play and run up and have an actual look face to face. So I'm happy with that. I think we can cruise on. Although, yeah, I'm happy with that. Okay, so save your instance. Go back to the world outliner. We'll delete our matte sphere mesh because we'll be making an actor. We'll be actually building functionality for the circle. We're not just making a material. And I haven't done one of these in a while. So to transfer into functionality, I think I'll use a Star Wars transition. Well, that was kind of cool. I like that. So, you're off in the Tatooine desert to go and rescue R2-D2 from the Sand People. You're going to need to turn your sphere into an actor. So just right click, make a new blueprint class. This is the actor, and this will be our circle BP. Alright, open that up, and we'll just add our matte sphere. Nope, we need a static mesh. Getting ahead of myself. Static mesh. Then click static mesh. Over here in static mesh on the right, this is where we plug in our matte sphere. Alright, and there it is. It's obviously going to have to be huge. And we'll set our material to the circle. Is that what we called it? Circle underscore, yeah. Why is that not showing up? Oh, I misspelt circle. Wow. Unbelievable. Not changing it. That's going to be how it is now. Okay, we'll set our scale up to 75. Make him big. Yeah, here we get a really good look at how the depth fade, not the depth fade, how the transition works. The near to far circle transition. Looks great. I'm a big fan. Okay, so we've got our sphere here. One thing we'll have to do before I forget is to turn off this generate overlap events, and we want it to overlap all dynamic. This will help us control when the player intersects with the sphere. So head to the event graph, and we'll start building this out. So we need the begin play, and at the begin play, well, we'll just grab our static mesh first, because we want to set generate overlap events to true when the game starts. Oh, but we want a delay as well. I mean, we could do this in like a config file for the actual project, but we want to wait just a little bit until the circle like enables itself. That way, everything is rendered, everything's loaded, everything's in the scene, and nothing gets tripped or interfered with before we're ready. So by delaying just a little bit, we'll let the dome, the overlap events for the dome, be enabled last in the scene, or at least later. This is just the simplest way. It's a little inelegant, but it's going to work for our purposes. Out of this boolean, we want a timeline to control the shrink of the circle. So we'll call it shrink. And we'll open it up. We want a float track. Call this one shrink 2, I guess. And make 2 keys. The first key wants to be at time 0, and the value, whatever we set our size to, 75. That goes up to 75. And this will set, well, the length. So over 30 seconds, it'll go from scale of 75 down to a scale of, we could say 15. Then just size this up so we can see it. Just 2 values, just a straight line. And this would be how we handle the shrink of the dome. Of course, you can use more of these with delays in between to set up stages. So it'll shrink from the biggest it gets to a little bit less, wait a bit, then shrink again to a little bit less, just by using multiple of these and various delay nodes. So out of here, we'll go update, set world scale. In fact, we might have to grab our static mesh again. Set world scale 3D. This is the node we want. And out of the shrink float, we'll plug it into scale. It'll convert it from a float to a vector. And the update into there, into that node. Hit compile, and now we can go back to the world, drag in our circle blueprint, which is now a gigantic big ring. And we'll hit play. And we should see. I should have moved the player start. We're going to be doing a little bit of walking. Here we go. So the circle is definitely moving in. And of course you can dial in these values in your timeline and whatnot to adjust for your needs. But the circle is going to move in, and when it gets to the size that we determined at the end of the timeline, it's going to stop. There it is. The circle is now stopped. Alright. Let's go back into our circle blueprint, and we'll control, actually not the circle blueprint, we'll go to our world settings, find our pawn, and open that up. Okay, so here in the event graph for our character, we'll need the begin play node. Actually, not yet. We'll make a new variable. This will be our check for whether we're inside the circle or not. Let's call it is inside, hit compile, and that will be all we need to do there. So back in the circle blueprint, get our static mesh, scroll down to the bottom, and we want to find on component begin overlap, and also on component end overlap. Then we'll get our player character. This is just fairly simple casting. Come out of here. We'll come out of here. Cast to our pawn, which is the third person player character. We'll make one of these for each, because we're checking when the player comes into the circle and when the player leaves the circle. So once we got our cast there going on, we'll come out of here and we'll set is inside. So when we begin overlap, we are inside. Look that up. And when we're ending our overlap, we're outside. Simple enough. I hope that's easy to follow. And then we'll compile and save. Next up, we'll handle dealing damage to the player when they're outside the circle. So make a new variable, call it health. I'm just going to do this in a very, very simple way. I'm sure you guys have your own systems for health and damage. But this is just the most basic that I could think of. So we've got health. We'll default it to 100 health. And we will make a, where are we over here? Make a new function. Call this one deal damage. Grab our health. Get. And we'll come off here into, well, we'll grab our, I'm in the wrong blueprint. So we'll delete that. We'll wind back. Come back to the third person character. Make a variable again. This is an integer. Compile. Set it to 100. Then make our function deal damage. Get our health. We'll get our is inside variable. Hold in B and click, and you'll get yourself a branch. Plug this into condition. So then, if we are not inside the circle, that is, if is inside is set to false, then we'll set our health to a little bit lower. So from our get node, we'll just hit minus, get an integer minus integer. Subtract 5, plug this into health, plug it into set, and we're done. In fact, we'll do something else so we can see it on screen. That's print string. We'll come out of this health here into this print string node. This is so that we can see the actual health change on screen. And that's our deal damage function. So back in the event graph, we'll get our begin play node now. And we'll come off the begin play with a set timer by function name. This function name is deal damage. We'll set it to loop and we'll set it to tick every second. This is another one of those values that you can change if you have different stages, and you can even sort of open up the function to take in some data so that the actual amount of health and the frequency that it gets taken off the player is all changing. But for the sake of brevity, and because it's all proof of concept, we'll cruise forward. And while we're here, we'll just get the game to print out our health right at the start, just like that. Hit compile. Oh, actually, I've goofed. So we want the damage to be dealt when the player is outside the circle, not in. So change this branch from true to false. My bad. Hit compile, and we're about ready. So let's just hit play. Actually, you know what? We can save us all some time. Where'd I put my player start? Over here. So if we grab this, and we'll just move it over. Did you know that if you hold in shift and move guys around, then it tracks the camera? And we want it to be up above the ground. So just drag it up there. And also, if you hit N, then it will snap the object you got selected down to the nearest surface. Pretty useful. Hit play, and you can see the little 100 appears on the screen. So we got our full health right now. We'll step out of the circle, and it starts ticking down, 5 health at a time. Nice. All right, we're nearly there. So the next thing we'll do, we'll head up to our third-person character, come to Add Component, and we will add a post process. Just like that, over in Details, make sure that it's unbound. Yep. And then we'll go back to the editor, and just for comparison, we'll place a post process. This is just for testing, which we will also make unbound, because we're going to have the colors of the scene change when the player is outside the bounds of the circle. So we got our post process here. We'll just use white balance. You could do anything you want with this post process though. I'm just using it outside the character so that we can test it out here and try out the colors before it gets into the game. So we'll turn on temperature and tint. I think we'll turn the tint. Yeah, we'll make things turn sort of a purpley. Yeah, like a purpley blue when we're outside the circle. And we'll just remember these figures for when we're in the player. So it's like 3500, we'll call it 0.24. So we'll delete that. Head back to our third-person character, and actually, as a default value, we'll just make sure that it's disabled to start with. Then we'll come back to our temperature and our tint. So 3500 and 0.24. Done. We'll hit compile, and now we'll make ourselves a new function. Over here, this will be change color. And similar to before, we'll grab our inside, our isInside boolean, make a branch, plug it in, hook that up to our function. And then all we have to do for this is just get our post process and set enabled. So we'll set it enabled when they're not inside the circle, and we'll set it to disabled when they are. So when it's false, hit the tick, make sure it's plugged up. And we'll set it to disabled for true. Hit compile and save. We'll go back to our event graph and we'll just add this to our tree. So duplicate the set timer by function name node. We'll plug that up to our tree. And this is the change color function. Remembering to get the spelling right. And we'll set the time to something quite a bit lower so that it happens sort of more or less instantly when the player leaves the circle. And the only limitation to this is that it affects the player, like the actual character, not the camera of the player. You might want to make another boolean for the camera if you'd like that little bit of extra thing. And now let's just go back to the editor, hit play, and we can see that the colors change when we move outside the circle. They're a little greener than they were when we tested them out. But here's where you can see the change. See, as soon as the player touches the circle, the colors all change. So you might want to make something else for the camera. Other than that, though, we are all good to go. We are set. And you see the health is ticking down. There's no death. There's no penalty for staying out. It's just an integer that ticks down. And now let's spend a little bit more time tweaking this material, because I'm not happy that the ceiling there is showing through. And it's upside down. At some point it must have turned over. Oh no, we know this. Yeah. So we'll come back to the viewport. Grab our dome and we'll just rotate it over. That's it still seems to be going backwards. We might go back to our material and add a 1 minus over to this side. But then we might have to turn it over again. We'll see. That seems to be working better. Yeah, that's more like the look that I wanted. So we'll compile that, come back to our landscape, our map rather, and we'll open up our instance. We'll play around with some more of these values. So let's see. First of all, we'll get our blend distance. We might lower that just a little bit. Cloud for now. I think it's the opacity that I really wanted to change, but that seems to have fixed itself. I guess because the sphere had to turn over. Yeah. So we're all good. Let's might make this blue color a little bit more blue. And if we wanted, I guess if we wanted more square sort of shapes here, then you just use some append nodes with the UV multipliers, which we can do. So if we duplicate this scalar twice, we get a far y and a far x. What am I doing? And then a near y and a near x. Feed these into an append. Make one for each. And we'll just append the x to the y and hook them up. So our far y, we'll make sure these numbers all match. And 200. Hook them up. Hit save. We'll come back to our map and let's, in fact, we can do it from the circle blueprint. If I had my instance open. Take that off. Get our instance going. So the goal here is to try and make the shapes as even as possible, which we can do. So the far, where are we? The far. Here we go. Stretch them up a bit, and the near ones will also need the same treatment. Just like that. Hit save. Close this. Let's go back to the editor. We'll have a little bit of a play. So, come out of the circle. Colors change. Back in the circle. Colors back to normal. And the damage is getting dealt outside the circle. See it's slowly ticking down. And when we come back into the circle, the health doesn't tick down. So that's pretty much the end of the tutorial there, fellas. I'd like to thank RJ and who requested this be covered on Discord. Much appreciated. This was a lot of fun to make. I'm really happy with how it turned out. And yeah, there's lots of opportunities for functionality. Like if you come back here to your timeline, for example, you can make the original like your small size bigger or smaller, or your big size bigger. We might just crank up these values a little bit. And like I touched on before, if you wanted to do this in stages, then you just come off here, you duplicate your timeline, put a delay in between, and make sure that the values of your timelines, they continually shrink down. Other than that, I think we're done here. I'll see you guys in the next video.